Alright, so continuing on this topic of mass to moles and moles to mass of two totally different substances, let's go the other way. This time let's start with moles of something and then try to find the mass of something totally different. So step one, like always, with molar ratio, with mass A to moles B, step one, we need to write out the balance formula. So after you do that, step two, you gotta look what you start with. This time I'm starting with moles, and I'm trying to find mass of something totally different. So if that's the case, if you start with moles, then do the mole ratio first. Because remember, the only way to go from one substance to another totally different substance is to do the mole ratio. So step two is change moles of compound A to moles of compound B by doing the mole ratio. So the coefficient of what you're looking for goes on top. The coefficient of what you started with goes on the bottom. Now, this will give you an answer in moles of B, whatever substance B is. But that's not what you want. You don't want moles of B. You want mass of B. So now that you have the moles, we're going to change the moles of B to mass by multiplying by the molar mass of whatever B is. And then I'm going to round my answer to the correct sig figs. So if I look at it this way, again, I take the given moles, so whatever moles are given to me, and this time I do the mole ratio first. Why? Because I already start with moles. You can't do the mole ratio unless you have moles. So now I start with moles, do the mole ratio. The coefficient of B will go on top. The coefficient of whatever A is will go on the bottom. That will give me my answer in moles of B. But I don't want moles B, I want mass of B, which is why I put 1 mole B on the bottom here, and I put the molar mass here of whatever the B is. So let's say I start with, let's just pretend I start with moles of oxygen, but I want mass of sulfur. So I'll write down however many moles I gave you of oxygen. Right here for this top part of the mole ratio would be the coefficient of sulfur. The bottom part would be the coefficient of the oxygen. Then that will give me moles of sulfur. But I don't want moles, I want mass. So now I'll put 1 mole of sulfur here, and I'll put the molar mass of sulfur on top, and then I'll get my answer. So let's look at an example. Determine the mass of the gaseous product when 0.53 moles of copper 2 chlorate decomposes. So we have another decomposition reaction, kind of like what we saw in the last video, but this time it's decomposing a chlorate. So I need to remember, when you decompose chlorates, what do you make? You make metallic chlorides. In this case, the metal will be copper 2, so it'll be copper 2 chloride plus oxygen. And then it says, figure out the gaseous product. Well, think, which is the product that's a gas? Is it the copper 2 chloride or is it the oxygen? Common sense says, yeah, it's the oxygen. So let's go ahead and write out the formula. Copper 2 chloride, or sorry, copper 2 chlorate, my bad, copper 2 chlorate, Cu, ClO3 parentheses 2, because copper's plus 2, copper 2, chlorate's negative 1, so I need parentheses 2. And again, that makes a metallic chloride, in this case copper 2 chloride, CuCl2, because copper's plus 2, chloride's negative 1, plus oxygen, O2, because oxygen's diatomic. And then I just need to put coefficients in. 1 copper, 1 copper. 2 chlorines, 2 chlorines. 6 oxygens. There's only 2 oxygens, so that's why I put a coefficient 3 right here. Okay. The hardest part, in my opinion, is done, which is writing out the balance formula. Next, step 2. Change moles of compound A to moles B by doing the mole ratio. So I'm just going to follow this equation. So I was given 0.53 moles of copper 2 chlorate. Now I'm going to do the mole ratio. So again, the one I'm trying to find the mass of the gaseous product. So that coefficient go on top. So I'm going to put 3 on top. And then the coefficient of what I started with goes on the bottom. I started with copper 2 chlorate. So that coefficient, which is 1, goes on the bottom, which you see right here. So now I have 0.53 moles of copper 2 chlorate times 3 moles of oxygen divided by 1 mole of copper 2 chlorate. Next, that answer gives me moles of oxygen, but I don't want moles of oxygen. I want mass of oxygen. So the final step now is to convert moles of oxygen to mass. How? We'll put 1 mole of O2 on the bottom, and we'll put the molar mass on top, which is 32. So in my calculator, I would type in 0.53 moles. Well, I won't put moles. I'll put 0.53 times 3. You don't really need to divide by 1 because it won't change anything. Times 32. And that will give me 51 blah 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 blah. Or it might give me 50.5 blah 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 blah. Whatever. The point is 2 sig figs. Why? I have 2 sig figs here. These are constants. They don't count. And then I have 4 sig figs here. So the fewest number of sig figs is 2. So my answer can only have 2 sig figs. So it'll be 51 grams of oxygen. And that's it. Okay. So again, stoichiometry becomes difficult because you have to ask yourself several questions. What am I looking for? What did I start with? If you start with moles, then you have to do the mole ratio first. And then you multiply by the molar mass of whatever B is to change it to grams. If you start with grams, though, then you got to divide by the molar mass of whatever you started with first, then do the mole ratio. Okay, so there it is. That is moles to mass, and we're done.